Next problem. Find the difference equation satisfying the relation yn which is equal to a 3 power n plus n into 2 power n minus 2. So we need to form a difference equation from the given relation. So in this relation you are having arbitrary constant a, that is only one arbitrary constant, right? So you will get the difference equation of order 1, right? Note that point. So we'll see how to find the difference equation, how to form the difference equation. Given yn which is equal to a into 3 power n plus n into 2 power n minus 2, that is equation number 1. Since there is only one arbitrary constant a, we need to find only the first difference, right? Because it is only one, order 1, right? Now yn plus 1 which is equal to a 3 power n plus 1 plus n plus 1 into 2 power n plus 1 minus 2. That is, replace n by n plus 1 in equation number 1, right? Now yn plus 1 which is equal to a into 3 power n plus 1 plus n plus 1 into 2 power n plus 1 minus 2 becomes minus 1. So 2 power n minus 1 is equation number 2. Now 2 minus 1, subtract the equation 1 from equation 2. So you will get first left hand side. So equation number 2 yn plus 1 minus equation number 1 left hand side yn is equal to equation number 2 right hand side a into 3 power n plus 1 plus n plus 1 into 2 power n minus 1 minus left hand side of the equation number 1 minus a 3 power n minus n 2 power n minus 2, right? Here, so first two terms, right? Comparing the first two terms of the right hand side, right, of equation number 1 and 2. So in both a 3 power n is common, take it outside, right? So you will get the second equation 3 power n into 3, right? 3 power n plus 1 can be written as 3 power n into 3. So there you are having in that particular term 3. And in equation number 1, you are subtracting that equation number 1 first term. So a power 3 power n, you have taken outside the bracket. So you have only 1, right? So a into 3 power n into 3 minus 1, first term. Come to the second term. So in the second term, the second equation, you are having n plus 1, 2 power n minus 1. The first equation, n into 2 power n minus 2. So n into 2 power n minus 2, take it outside. So when we are grouping these two, right, take it outside, n into 2 power n minus 2. So you will get in the first, second equation, n into 2 power n minus 2 you have taken. So remaining you are having, so n into 2 power n minus 2, then 2 into, because you are having 1 2, right, 2 into n plus 1 by n, right? You have taken n outside. So n into 2 power n minus 2 into 2 power minus 1, right? Because you are taking 2 power minus 2 outside. So you need 2 into 2 power minus 1. Then only you will get 2 power 0, that is equal to 1, 2 power 0, 1, right? So in the second one, you need 2 power n minus 2 instead of 2 power n minus 1. So you will get 2 into, so you are multiplying 2 and 2 power minus 1. So you will get 2 power minus 2 into 2. That is what you are having, 2 into n plus 1. And you have taken n outside divided by n, right? So this is equal to 2 into a 3 power n, 3 minus 1 2, right? 2 into a power a into 3 power n plus n into 2 power n minus 2. So taking LCM inside, minus 1 into n minus n plus 2n plus 2. You are multiplying with 2, 2 into n, 2 into 1, whole divided by n. So which is therefore yn plus 1 minus yn, which is equal to 2 a 3 power n n into 2 power n minus 2 plus 2 into 2 power n minus 2, right? You are multiplying with that, right? So you are getting this one, right? Because n into n get cancelled, because you are having, when you are multiplying, so you will get n into n get cancelled, so you will get remaining term, right? 2 power n minus 2 into n plus 2 power uh, n minus 2 into 2. 2n minus n, you will get n. So you are having n plus 2. So n plus 2 means 2 into n into 2 power n minus 2. So n get cancelled. And second term, you are having 2. 2 into n get cancelled, 2 power n minus 2. Right? So that is equal to 2 into a 3 power n into 2 power n minus 2. So 2 power 1 into 2 power n minus 2, grouping that one, minus 2 plus 1, you will get minus 1. That is equation number 3. So 3 minus 2 into 1, right? So 3, yn plus 1, right? Left hand side we are taking yn plus 1, 2 into first equation, minus 2 into yn, right? That is left hand side. Now come to the right hand side. So yn plus 1, 2a 3 power n plus n into 2 power n minus 2 plus 2 power n minus 1 minus 2 into first equation, minus 2 into a 3 power n minus 2n into 2 power n minus 2. So grouping this, so 2a 3 power n minus 2a 3 power n get cancelled, because we have to eliminate a. That is what we are doing. So whatever the possibilities, you make it and remove that the constant, right? What arbitrary constant, right? So 2 power n minus 1 remaining, minus then n 2 power n minus 2 minus 2n 2 power n minus 2, balance you are having 1 minus 2. So you will get minus 1. So minus n 2 power n minus 2. So right. So taking 2n common, so take it outside. So first term 2 power minus 1, that is nothing but 1 by 2. The second term minus n is there and 2 power minus 2 is there, because you have taken only 2 power n. 2 power minus 2 becomes 1 by 2 power 2, that is 4. 1 by 4, that is n by 4. So 1 by 2 minus n by 4. So 2 power n, then taking LCM, 4 is the LCM. So 2 minus n by 4. So 2 power n minus 2. So into 2 minus 2, because 4 can be written as 2 square. So bring it to the numerator. So 2 power n into 2 power minus 2. So grouping that 2 power n minus 2 into 2 power n. So yn plus 1 minus 2n, 2yn, which is equal to 2 power n minus 2 into 2 minus n, right? So this is the equation, right? Where that is the difference equation in which there is no arbitrary constant, right? Next problem. Find the difference equation satisfying the relation un, which is equal to a into 2 power n plus 1. So given un, which is equal to, that is alpha or a is a constant, into 2 power n plus 1, that is equation number 1. Since there is only one arbitrary constant a, so we need to find only the first difference. So un, so difference is un plus 1, right? So first difference, just adding 1, right? So you can find the difference of un minus 1, but better to take plus 1, that is what, right? Easy to calculate, right? So un plus 1, which is equal to a into 2 power n plus 2, replacing n by n plus 1, the equation number 1. So you will get this one. That is un plus 1, which is equal to a into 2 power n plus 1, separating 2 from 2 power n plus 2, right, into 2. But a into 2 power n plus 1 is equal to un, that is equation number 1, replacing. So un plus 1, which is equal to un into 2. So un plus 1, which is equal to 2 into un, right? There is no arbitrary constant a. That, so this is the difference equation for that particular relation. Thanks. We'll see in the next video.